Hello, my name is Siddharth Varde, and today we are going to talk about pointers. So, like, what is a pointer? So, pointer is nothing but a special kind of variable that holds a memory address of another variable. So, like, if I create a typical variable, I have to define a value, assign a value to it. So, like, what it holds. But when I create a pointer, I need to assign a memory address of another variable to hold. So, when I say okay, edit the edit the pointer variable, increment or decrement or any other thing, like edit the value, so it goes to the variable that I assigned the memory address of, and then changes the value at that memory address. So, like, at that, in that variable. So that is the main difference between pointer and a normal variable. So let's say, pointers are kind of reference type, not a value type. So like, if you change at one position, it will change at every position, kind of thing. So that is the thing. Or pointers, like, okay. So like, this is the syntax of a pointer. Like, it is the actual pointer that we can define like this. In like, the actual syntax is like the data type, then the star, and the name of the pointer variable, and then the, like, semicolon. There is no assignment yet, but like, as I said, if we need to assign a value to it, we can't just assign a value, normal value, integer value or something. We need to assign a memory address of a variable of integer type. So, uh, so like, to do that, how can I do that? There is an operator, ampersand operator, that allows me to access the memory address of a specific variable, and like any variable, not any every like, I can access the memory address of every variable. So let's say I created an integer and I assigned a value of 10. So if I need to store the value, variable x inside a pointer, so I need to do it like integer pointer p is equals to ampersand x. So, like, this will show give me like the memory address of x, like store the memory address of x inside an integer pointer. So, like, here, and like, let's say every pointer is still a pointer, right? So every variable has a value and memory address, but every pointer has value. So, like, that value is like the memory address of another variable, the memory address of themselves, and okay, the value of pointer. So, like, the memory address of the variable that they're storing, value, yes, value at pointer. So, like, that's the value that is stored on that memory address, the value of that x variable in this case. And then the third is like the memory address of itself, the pointer itself. So uh, uh, like, here, and we, if, like, we can allocate and deallocate the point, like, memory for the pointer using new keyword and delete keyword in C++. So, like, here is the example. uh, I defined an integer a, and then I assigned it to the pointer p, integer pointer p, ampersand a, and then value of a, I printed the value of a, then the address of a, then I printed the value of pointer p, then the address of pointer p, and then the value at pointer p, or value of star p. So it's like value at pointer p, and that is the same value as the value of integer a. definitely. And then okay, like let's look at this first. I run it and here we go. Value of a is 10, that's correct as we defined. Then address of a is this, it will be different every time. Then the value of p is the same memory address of memory, like that's the memory address of a, right? So that is the value. Like you see here, I if I print a, I get 10, but if I print p, I get the memory address of the variable a, right? So like that's the value of p. Yes, here, not there, it's here. So like that is the value of p, as same as the memory location of variable a. So that is that. And then like that pointer p itself holds a memory location, so it has a memory address of its own. So that has a different value than the value of a, sorry, like the memory location that of a. So like it's a different location, as you can see. And then the value of pointer p, or value at pointer p, is 10. So that's the same value as variable a. So now let's look at the new keyword. So like I can assign a pointer using new keyword, like I can allocate a pointer using new keyword. So why do I need to use new keyword, like we assigned like here, right, without using new keyword? So the difference between these two is the first one, this normal pointer p is like static allocation that I defined at compile time. Okay, so like and this one is the runtime. I can define it on the runtime using new keyword. So I can allocate or deallocate memory on the runtime while the program is running. So that is the major difference between these two. So like let's say if you are using like you created a game and game is running, and in the running game you need to create something, so instantiate something or create an object. So like that we can do using new keyword, like allocate the memory for it and then deallocate the memory for it using delete keyword. So these are the two special keywords. So then again I printed the same things, like value of pointer q. Okay, so that would be 20. Then value of q, so like that would be the memory address of the pointer q, and address of sorry, no, value of q is would be the memory address of this new variable, unnamed variable 20, that holds the value of 20. And then the address of q is ampersand q. So that is it. And then I have deallocate the memory at q, but the variable itself is sustained, like I didn't delete the variable, like I cannot okay. So I deallocate the memory that it is pointing towards, so there is nothing that it q now points towards. So it will give me the garbage value at that memory location. So like what is allocating a memory? Okay, let's say, so when I allocate a memory, I just specifically tell the computer that this memory is occupied. No other program can occupy it. No other program can use it. Okay, and if when I deallocate it, I say to the computer, okay, now this memory location is free for use. You can assign it to any other program. I don't need it anymore. So that is the allocation of memory and deallocation of memory. So like when I deallocate it, so that memory address still exists, right? So it, like there is something at that memory address, but that value is from some another program or maybe some old program. So like that's the garbage value that we will get here. Okay, so this is like from here, let's say I created a value 20. So value of pointer q is 20, right, star q. And then the value of q of itself, value at q is 20, and the value of q is the memory address that this 20 this variable is stored that holds the value of 20. So this is the memory address of 20. Okay, and then there is a memory address of q itself. So this is the memory address of q itself, and after the deallocation I get the garbage value. So this is it about the pointers. Thank you.